Okay, here we're trying to use the calculator to evaluate or approximate several logarithmic functions. The problem is that these logarithmic functions have different bases, right? Our calculator only has two logarithmic buttons, typical TI-84 style calculators. The TI Inspires and some of the newer ones you can put in an arbitrary base, and so this is a little bit less aimed at that type of calculator evaluation. It's still an important technique to know. It's still an important strategy to know. This is going to require us, we have a log of x, which is our common log. And that's the same thing as log base 10 of x. And then the other button we have on a typical calculator is the natural log. It's that ln of x, or it might be written, a lot of calculators, it's ln of x. I just typically don't like writing it that way by hand. It's again very often log of x. It's the same thing, log base 10 of x. This ln, this is going to be log base e of x, and this is my natural log. And so the calculators, they typically only have common logs and natural logs. And if you're starting to use a new system, you always want to make sure which one is declared as which, because this is standard. But I have used systems where it was actually defined exactly opposite of this. Not exactly opposite of this, but where log was just assumed to be the natural log, even though it was spelled out log, because natural log is at this point far more common than even the common log. But the 84s, which is what we typically use in this class, these are the two ways these are defined. Log is common log, and that's base 10. ln is natural log, and that's base e. Now, how do I evaluate log base 4 on a calculator that does not have a log base 4? Well, I have to change the base to be either one of the bases that I have. This value here is the base of the logarithm, right? And the way we get that is we get that directly from that definition of a log, right? Because we had that our log base a of x equals y is the same as a to the y equals x, and that is the base of my exponential, right? So this is the base of my exponential. And so this is the base of my logarithm. Okay, and so what I need to do is I need to change the base of these logs before I can use the calculator to approximate their values. Well, that's going to require a formula. And the formula that we have for that is that my log of my new base of a value, let's just say the log a of x, right? And so this is the logarithm, well, let's write that a little cleaner. I have log base a of x, and that's any one of these logs, right? So I could have log base 4 of 100, log base 3 of 20. It's just any logarithm can be rewritten with a new base as a ratio of log with my new base b of x over log of my new base b of my old base. And so that's a constant, right? And so this is the scaling constant that takes my variable, right? And that takes my log function of a variable and scales it to become what my old logarithmic function was. Okay, and so let's use that. That means that this is the same thing as the natural log of 100 divided by the natural log of 4. And so if I go to my calculator, I could type in natural log of 100 divided by the natural log of 4. I get approximately 3.32. Just for the fun of it, let's do this one with common logs. If I do that, what's going to happen? I'm going to have the log of 20 divided by the log of 3. So I have log of 20 divided by the log of 3. That'll give me approximately 2.726. And you can see we can keep doing this, but real quick, let's test this idea that we could change it to any base we wanted to by also doing that same. Let's do this same log of 20, log of 3. But let's do that with the natural log. Let's do it with a different base. And so if I do that with natural log, come on, there we go. Natural log of 20 divided by the natural log of 3. All of a sudden, I'm getting the same thing. And if I do the natural log of 100 divided, I did that with natural logs already. So let's, instead of doing that with natural logs, let's do that with logs. And so do log of 100 divided by log of 4. And take a look, I got the same value. And so you can see that I can change this to any base I want, and this ratio will still be the same because I'm actually evaluating log base 3 of 20 or log base 4 of 100. I'm just doing it by converting my bases to something else. And this is particularly clear in an example like this one where I've got an irrational number for my base here, right? Because that's just not something that we'd be able to do on a calculator, except that now I can say that this is the natural log of 100 divided by the natural log of pi. And so then that's going to be approximately natural log of 100 over the natural log of pi. And then I get 4.02. And then so with this last example, I'll have, let's just do common log, log of 100 divided by log of 9. And so that'll be approximately log of 100 divided by log of 9, 0.96. Something like that. So this would be how to use that change of base formula to evaluate logs in our calculator that we wouldn't have otherwise been able to evaluate. Hope that helps us.